having to take a lot of math home. So in the arithmetic sequences, we already learned the formulas. It's kind of like, well, what's left to go here? We filled in the boxes on the front of our packet, but there are a few things that we haven't done yet, and we need to take a look at them. So define, we know what they are. If they're adding the same amount every time, and they might be adding a negative number. Identify, on the test, it's going to say, is this arithmetic, is this geometric, or neither, and then, do things with it. So that's key. And then apply, that's us saying, well, let's go grab that formula that we have. A sub n equals a sub 1 plus the quantity n minus 1 times d, and do some math with it. So one of the things that we don't have a spot for on the front of your packet is something I probably would have put a spot for if I had made that front page. And that would be finding a middle term. So if they give you two terms and all they ask you to find is the one that's right between those two. There's a really easy way to do that, because what we're doing is we're finding the arithmetic mean. And most of you took the course Probability and Stats. So hopefully you're looking up there and you're saying to yourself, mean, isn't that the average? Isn't that where you add them and then divide by 2? And that's exactly what we do. So if we are just missing the middle term between two others, we just add them together and divide by 2. So that's where this little formula comes in. So on the front, you might want to write arithmetic mean, and that's supposed to be a plus. X plus y, kind of looks like a minus up here. X plus y divided by 2. So in an arithmetic sequence, the middle term of any 3 consecutive terms is the arithmetic mean of the other 2. So these are going to go fast, but you start to think, so is there such a thing as a geometric mean, when we do the next ones? And there is. We'll get to that. But today is about the arithmetic. So what is the missing term of the arithmetic sequence? And I notice, hey, it's just missing a middle one. So if I take 15 plus 59 and divide it by 2, that should find me the middle term. And if you don't want to do that in your noggin, you wouldn't have to. So there it is. Again, this is just used if we're missing a middle term in there. Now sometimes they'll do this. They'll give you the first one. Let's see, how will they do this? Yep, that'll be enough slats. So they'll give you this first term, and they'll give you 1, 2, 3, 4, 5, the fifth term. And we could use the formula, write it, and then get second, third, and fourth terms. But if they tell you have to use the arithmetic mean, what you're going to do is add these two together and divide by 2 to get the middle term. And then you'll do it 2 more times, because now you have another set, another 2 sets that will have first term and third term, and you'll be able to use it. So we have different ways of doing this once we use the rules. If we want to keep using our formula, we certainly could do that, but we can also use the arithmetic mean. Alrighty, so here's the got it. The 9th and 11th terms of an arithmetic sequence are 132 and 98. Okay? So I make a little visual, and then I can absolutely see, oh, well, and I'm still just looking for the middle one. That's all I'm doing. So, again, don't want to have to use your noggin for anything. There it is. And we have 115. So, arithmetic mean. Is it a new formula? Yes and no. I mean, in province statistics, you found averages all the time, so It's probably not feeling like a new one. But now B kind of challenges our thinking. It says if you know the fifth and sixth terms of an arithmetic sequence, how can you find the seventh term if they say you have to use the arithmetic mean? Well, it's set up so that we're supposed to find everything. So if we're using the arithmetic mean, we know we'd have to take a sub 5 plus a sub 7 and divide it by 2 to get a sub 6. But here's what they're saying. You already know a sub 6 and you already know a sub 5. What you really want is a sub 7. So that means we need to solve that little monster for a sub 7. So let's see. This 2 can't be here to do that. How are we going to get rid of the 2? Multiply both sides by 2. We still want a sub 7 all alone, so what would we need to do? Way back in first semester, these were called literal equations when we did this, when we had lots and lots of variables. And way back at the beginning of semester 1, they looked very scary with lots of variables. But you are now master manipulators of numbers and letters because you've been in Algebra 2 for a year. So that's what we would do. We could take 2 times a6 minus a5 and we could find it using that mean. Well, we can't be done because we haven't done a word problem yet. So now we need to do the word problems. So obviously when we're talking about arithmetic sequences, we're saying to ourselves, there's got to be a lot of numbers in here that are going to be important to me. So that's what I want to keep track of when I'm looking at a word problem. The numbers of seats in the first 13 rows in a section of an arena form an arithmetic sequence. Ooh. Good to know. I want to resist the urge, but immediately I want to write down our rule because I'm pretty sure they're going to ask us something about that. But let's just wait and see. Rows 1 and 2 are shown in the diagram below. How many seats are in row 13? Yep, that's what I need to do. Because they're going to ask me to throw a 13 in there and see what I get. We did this yesterday. There were 2 of them that we had to replace with numbers. What's one of them? D. All right. It says row 1 in the picture has 14 seats and row 2 has 16. So what's D? Yeah. So we're going to have to put the 2 in there. What else do we need to write the formula? The first row. Do we know how many seats are in the first row? Yeah, it's in the picture, right? 14. So we are always replacing a sub 1 and D. Now, in the past, on that front sheet of your note packet, I've told students if you think you're going to forget that those are the 2 that we need to put in. If you have a highlighter, a great thing to do would be to take a highlighter and highlight a sub 1 and D. So you remember that those are the 2 that we have to replace with numbers. Because now, we're just going to do a little algebra. And we have our little formula. And, as I mentioned yesterday, our last test, what I decided to do is, those of you that are in class, I'm not going to have you do it on the Chromebook. I'm kind of worried we might crash Schoology with everybody taking the test that way on the last day of school. So you'll have an actual paper test in front of you. But like I said, almost all of them are multiple choice or fill in the blank type of problems. So we're not done with this one. We'd get most of the points, but we're not done because we haven't done what? Exactly. We didn't plug in the 13. So what do we have? 26 plus 12. 38 seats? So is it a word problem? Yes. Are we just searching for the numbers to put in the right spots? Yes. I mean, that's all we're doing, is trying to figure that out. So now, this one needs more of you and less of me. I got it. The number of seats in the first 16 rows in a curved section of another arena form an arithmetic sequence. If there are 20 seats in row 1 and 23 seats in row 2, how many seats would be in row 16? So, what are we going to do? Yeah, let's get the formula written down so we can start thinking, hey, these are the ones I have to replace. What do I replace and with what? D is a 3. This was 20 seats and this is 23, and it's row 1 and row 2, so they're one right after another. What else do I replace and what should I use? 1 is 20. A sub 1 is 20. Well, let's pretty it up. Do a little bit of algebra. Distribute. And combine like terms. Done? We've done most of the work. What's the last step here? Yeah, plug in a 16. $48 plus 17? Yeah, let's put it up here just so everybody can see it. So you know you wouldn't have to do this in your noggin if you didn't want to. There it is. Arithmetic. Henry.
Would it be alright if you use something in 16 when you're first putting in numbers for n? So you points for that on the test.
Oh, up here you mean?
Yeah.
No, we always simplify. Yeah, you do lose, for not doing the simplifying piece, you will lose a little something, you know. The problem with that is, as we get multiple formulas, sometimes students forget which ones are supposed to go in for what. And so it's much easier if you simplify it first and put it in. So Henry's asking this. He's saying, can't we just put the 16 in up here and get the same answer? And the answer is yes, you can. But part of what we're testing in, well, it's the major thing we're testing in this chapter, is your use of formulas, and that you can simplify formulas. We're really kind of checking again, are you better at literal equations than you were in first semester? I already know the answer to that. It is absolutely yes, you are, you know. I remember when we did literal equations in first semester, and they were stuff like this. And I'd ask people, how do we solve for r? And you could hear crickets chirping in the room. Divide by pi, take the square root. Now it's a piece of cake. But we've got the benefit of a whole year's worth of algebra too, so you're much better at it now. So that's it for this section. So let me get you some homework here, and you can get started. Like I said, there's a good chance you'll finish this too before you get out of here. So, lots of books to borrow over there. I really thought this morning, well, maybe I should start teaching a little bit of 9-3. I don't want them to run together in your head. So, 9-3 will be a video lesson tomorrow. I think it's about 18 minutes long.